Hello, and welcome to this episode of the K&Co Tech Podcast. I'm your host, Shelley Kramer, Principal Analyst here at Kramer&Co, and I'm joined today by Chad Meley, who's the SVP of Marketing and Developer Relations at StarTree. Chad, welcome. I'm so glad to have you.
It's great to be here. Thanks for having me.
Absolutely. Well, our conversation today is focused on the next gen of enterprise intelligence and where AI native real-time analytics and bring your own Kubernetes are soon to be center stage. Chad, I know that you and the StarTree team have some news on that front, and I'm really looking forward to diving in. So without further ado, I want to get started. And I always like to start these conversations by asking a little bit about your career journey. And I know that you've got amazingly deep expertise in all things SaaS, big data, AI, and advanced analytics. And you've had some impressive roles at Connecticut and Teradata and EA, Dell, and FedEx. I mean, like, what haven't you done? Will you share with me, though, Chad, a little bit more about that journey and how your passion and expertise in AI is playing out career-wise?
Yeah, for sure. It's certainly been an interesting journey. I've sort of always had an interest in business operations, particularly marketing, as well as what data and analytics can do to really inform decisions and reinvent processes. So throughout my career, I've kind of bounced back and forth between marketing and IT engineering roles, building data platforms and analytic teams. As far as AI goes, people come at AI from different places. Certainly, I come at it from a historical perspective of data management and building data warehouses, data lakes. And I would say, like, around the rise of big data, I was working at Electronic Arts, and we first started really getting into machine learning and noticing a real difference around that versus traditional data mining and statistical analysis. And then later, I was fortunate enough to get involved with some consultants that were doing very cutting edge deep learning around 2016, very ahead of the time, and really developed a real interest in GPUs and these new frameworks. And that inspired me to go get a doctorate, which I completed just a couple of years ago, where I did my dissertation on artificial intelligence. And the thing about being, in the data management space right now is it's so being disrupted and affected in a good way about artificial intelligence. So there's always, new things that keep it interesting and exciting.
Yeah. Oh, absolutely. And what I love about this part of our conversation is that, people think that AI is something new. It's not. AI has been around for a long time, and we have been surrounded by AI in many ways without even being aware of it. Netflix serving up recommendations based upon your behavior, and the having an Amazon Alexa in your kitchen, and all the Siri is an example of AI. And so it's really interesting that to be in this, what I like to call the age of AI, but really a lot of us have been doing lots of things in the AI space for a very long time.
To that point, someone said once, and I still get a chuckle out of it, that once we give it a name, it's no longer AI. So machine learning was synonymous with AI, but now that's just machine learning, right? And then deep learning, and no, that's not AI. It's this new thing. Oh, but now it's called Gen AI. So whatever is next is AI. And if it has a name, it's already infiltrated things and feels more familiar.
Yeah, so very true. So very true. Well, Chad, there's no conversation today that, of course, doesn't focus on AI in general and AI agents in particular. And, today AI agents are truly redefining application intelligence. What do you see that distinguishes AI agents from traditional apps? And why is real-time data so critical to their functionality?
Yeah, if you think about AI agents, what really distinguishes them is they're acting autonomously, they're interacting with multiple different systems, they're goal-oriented. And as I said, they'll autonomously act on behalf of the user if allowed to do so. And I think there's an interesting comparison between agents and mobile apps. By the way, we work with a lot of companies that are infusing analytics in their apps, like Uber, Stripe, DoorDash, right? Where you have to get these kind of intelligence. But if you think about like how you might interact with someone like DoorDash in the future, it's probably not going to be going into an app that's very rigid and predefined. It's probably going to be something like, hey, I want to have a team offsite, and agent, go out and order lunch for the team, right? Now the agent's off, it's checking what our corporate policy is on expenses. It's maybe sending emails to the team, getting input on what we should order. But part of what the agent's doing too is it'll interact with DoorDash and figure out menu options, pricing, delivery times, all these different insights that inform ultimately the action being taken. And so I think we're going to see over the next several years a shift away from getting on your phone and interacting with an app to just having your agent work across multiple companies to ultimately give what you're deliver what you're after.
I love it. I very much look forward to not having to wade through all of those many details, right?
Yeah.
I mean, yeah.
One other thing to add about it too that I think is interesting is, one of the reasons that, we tend to work with a lot of companies that are, on these high frequently utilized apps is this idea of concurrency, right? So if you're an Uber, you might have something like 30,000, 40,000 queries per second as people are, evaluating like different pricing and, how long is it going to take for the ride to show here. But when you start thinking about agents interacting with an Uber or a DoorDash, it's going to take what the traditional levels of concurrency are that are human driven and then multiply it by like an order of magnitude.
Yeah.
Because you're just going to have these swarms of agents that are out there polling and requesting information from various sources to try to optimize the outcome.
Yeah. I just had this vision pop into my head of like this huge crowd of agents trying to get stuff done.
Right.
Right. So let's talk a little bit, Chad, if we could, about technologies. Like, what role do technologies like model context protocol and natural language to SQL play when it comes to enabling AI agents to deliver those decisions dynamically? And the second part of my question is, I want to know what role the technologies play, but I also want to know more from you about how StarTree is integrating with those innovations.
Yeah, for sure. So God, I guess we're like 2.5 years now into, OpenAI and ChatGPT really like changing our world, right? But, I, as a database guy, an analytics guy, I was really optimistic early on that the way we'd work with data would fundamentally change, that we'd use more of a prompt level interface like you'd see with OpenAI, that we would not be writing SQL, but we'd just be asking questions in natural language and we'd immediately get an answer back. And while there's certainly vendors can produce some demos that look like that, it really hasn't gotten traction yet, right? Where that's the new reality, like that's how people ask questions. And there's a couple of reasons for that. One is those integrations have tended to be very brittle. They're like very hand coded and maintained, and they might work for one system, but not another. So it's really prevented wide scale adoption. And I think that's what MCP or Model Context Protocol is all about. You can almost think of it as like an API layer that allows any model to communicate with any system so long as it has this MCP layer. And that MCP layer is really an abstraction, right? So again, I could have any model. It could be Anthropic Claude, it could be OpenAI. And so long as your database or any system has this MCP layer, it can ask questions of it, and those are then effectively translated to interact with the backend system. Right. This has really blown up in the last couple of months. I think it's going to be the new standard in which these AI agents integrate with systems. And so we've embraced that. We just made an announcement a couple of weeks ago. In fact, I was just talking to the engineers next week. We'll have it out in the wild for people to start testing and utilizing. And what MCP on top of StarTree will allow you to do is you can have an agent that if it needs up-to-date insights, right? Again, if it's something like your DoorDash delivery times, that agent can very quickly calculate what those delivery times are on the freshest possible data by going through this MCP layer.
Yeah, that makes perfect sense. That's very cool. So let's talk now a little bit, if we could, Chad, about real-time retrieval augmented generation. And so this is likewise, like MCP gaining traction. How does this approach, though, differ from standard RAG models, and what makes it so valuable in these high-velocity data environments that we're talking about?
Yeah, I think the key is real-time RAG, right, versus
Yeah.
batch RAG. So just a
Yeah.
reminder, batch RAG, or I mean, people just call it RAG.
Right.
But, that was invented to really provide additional context that a large language model might not have, right? So I could ask a large language model a question around, I don't know, something proprietary to StarTree, let's say, right? Like, how many employees does StarTree have? If that's not public information, I can have that in a RAG database, and the LLM can query that and answer that question.
Right.
And there are a lot of really interesting applications of RAG that companies have explored to, again, augment the knowledge of an LLM. But most of those were designed to do things in batch, where you do these periodic loadings of data every day, every week. But what that then prevents is use cases where you need very fresh, up-to-date information. So if I was trying to do, let's say, utilize an LLM to assist in detecting security threats in my environment, well, it wouldn't be good enough to detect those a week after they happen, because that's when I'm good in my RAG database, right?
Right.
You might want a continuous stream of insights coming into, or data sets coming into your RAG database that are then wired up with your LLM. So when it is trying to augment the information, it's guaranteed to have the freshest possible insights associated with that.
Which, from a security standpoint, that's of course what you need. And as these things go, you kind of set the stage perfectly. You teed me up for my next question, talking about security and fraud detection. So how are real-time vector embeddings changing the game, especially when it comes to analyzing those transactional anomalies?
Yeah, I'm really excited about this topic. The idea of vector embeddings, I think a lot of people, myself included, when we first came to learn about these, it was taking things like text or images, data sets that were really intractable from a data analysis standpoint, converting them into these vector embeddings, and all of a sudden you could query them in ways you could never do before. But what's, I think, really interesting is now there's a lot of vector embedding models that allow you to do embeddings on more structured data, like logs. So here would be an example of that. I tend to learn these things sort of through example, but imagine, let's go back to like security data. Let's say you've got all these logs in your environment and you're trying to figure out, should I be concerned about this particular event? Is it a threat or not? Now, typically the way we do this outside of vector embeddings is we're doing very deterministic things, and typically like hard and fast rules. Like, does this event violate some sort of thing that I'm looking for? But when you take a log and you convert it into vector embeddings, you can do something called vector similarity search, which means it doesn't have to be exactly like something, but you're basically saying, does it follow a pattern or look like something? So now what I can do is I can say, hey, we just had this log. Should I be concerned about it? And the AI can then say, I've done extensive pattern matching over things that turned out to be issues and things where there was nothing to see there. And it turns out that this particular event more closely resembles things that you don't need to be concerned about. That's not the way databases typically work, right?
No, not at all.
Hard and fast, very precise, equals greater than things. So the ability to convert this more structured, semi-structured data into these vector embeddings really just allows you to do pattern matching on steroids. And what excites me too at StarTree, because we're all about real-time data, is this ability to then, calculate these vector embeddings in near real time, very quickly load them, give them a vector index, so you can ask very important questions like, is this something that's fraudulent, or is this a security risk, or is this something that from an observability standpoint is degrading our system? There's many different use cases where you can have this sort of pattern matching on steroids unlock, all sorts of value.
Oh, I love it. Well, as somebody who's not only a data geek, but also covers the cybersecurity sector, this might be my favorite part of the conversation because this is really, really cool. And the ability to have that information, that analysis in just moments is really exciting.
Yep.
Yeah, very, very cool. So I know that observability stacks are shifting really, really quickly. Chad, what kind of trends are you seeing as organizations move away from those monolithic monitoring platforms that they've been using for a long time now?
Yeah, there's been a trend that's happening for a little over a year, really brought on by something called open telemetry. But if you look at the vendors that really dominate the observability space right now, the way they go to market is they have this end-to-end solution around collecting logs from your system. They move it into a central repository. You can analyze it, detect anomalies, you can visualize it. But everything I just described as like a data warehouse, data lake practitioner historically, I always thought, well, like, why do people build separate systems just for observability? That sounds like any data management problem, right? Collect the data, structure the data, analyze the data, visualize the data. But if you look back around, like, why do we even have observability vendors? It's because the observability vendors really invented something that they held on to be proprietary. And that is this code that you put in your code that instruments the code to then detect and generate all the data that becomes what you analyze to see if your system has a problem. And so rather than just going to market with that, they built a whole ecosystem around it. Well, now you have open source instrumentation of that. So you no longer, like, sort of the original proprietary value proposition of observability vendors is no longer in place now that that's been disrupted by open source.
Right.
And so what that's left a lot of people with is like, okay, great, this is awesome. I can save a lot of money. Now I can get more agile, but I am gonna have to build a solution that's not turnkey. Many vendors are totally comfortable sort of rolling their own and building their own observability platform, but they're asking a lot of questions around what are the best in-breed piece parts of that. So we know we've got OTel for the collection part. Typically, we see a lot of people using things like Kafka to then move that data to some central repository. Grafana is a great open source option for visualizing it. Kind of the jump ball out there is really like, what's the best database to put this information in? And increasingly, we've seen Apache Pinot and StarTree, by default, get embraced for a lot of this because we have a lot of the attributes that are necessary for observability workloads. We can ingest the data very quickly. We can index it very quickly. We can store logs, metrics, and traces all on a single platform. You want to interrogate the data and get like sub-second responses. That's always been a hallmark of Apache Pinot. So ticks a lot of the boxes associated with it. In fact, someone could maybe put in the show notes, O'Reilly just came out with a book on building an open source observability stack. And that's actually received a lot of downloads as people are really interested in this topic.
Well, I think that I think of it's some ways like composability. This modularity is incredibly attractive because people are concerned about vendor lock-in and making decisions that we all know whose butt's on the line when I recommend that we go this way or whatever. And so I think that the move toward open source, this modularity brings choice. I think it brings a little bit of a comfort level too, because we can go this route and see what we think. And if we decide there may be a better solution, we can slide this one out and slide that one in. And I think that is, I think that's a good thing.
That's very well said.
Yeah.
And we've seen this pattern before. Again, as I mentioned, I've come from the data warehousing world, and there was a time not that long ago, like within the last 15, 20 years, where if you were a company and you wanted to buy a data warehouse, you'd go to an Oracle, an IBM, Teradata, and you bought everything, not just the software, but they sold
a shit ton of money.
Oh, yeah. They picked the drivers, they picked the network interconnect switch. If you want a different one, you can't have it, right? And And, there's some value, right? And like, oh, it's a turnkey solution, but really in the market spoke, no one buys a data warehouse that way, right? It's like, I
Yeah.
want to buy my relational database or columnar database from Snowflake. I want my compute from this EC2 instance on AWS. I'll pick my own visualization layer, I'll pick my own storage. And by mixing and matching, you can just, dial it into your exact needs. And as you said, you can easily swap out things if, to avoid vendor lock-in.
Yeah, it's not just that. It's not just the vendor lock-in, although that really is a big part of this equation, right? There is a fear of getting stuck, and that's a really real fear. And so I think that the ease that you can personalize what it is you need, as opposed to I have to work around the nuances of this particular offering, this particular platform, this particular solution, and being able to address sort of, we all have some pretty interesting, unique needs. And I think that this is attractive. Certainly, I'm glad to see that we're going this way, because that modularity is a big deal.
Absolutely.
Yeah. So let's talk a little bit, if we could, chat about what's ahead. So as you see more businesses adopt real-time analytics, are there some industries that you see leading the charge? And if so, what are they doing differently?
Yeah, so there's certainly some industries that I think are ahead of others right now in terms of embracing real-time analytics. See a lot of it in fintech.
Yeah, I wouldn't be surprised. I mean, that's very common.
And we work with Stripe and Nubank and Razorpay. They're the biggest fintech in India. And, what they're interested in is not only just detecting fraud, but a big way that they create value and retain customers is they give the data back to their merchants, right?
Okay.
So if you're a Stripe merchant, you're using their platform, you can log on to Stripe and get your own cash flow analysis or understand your churn, right? So they're giving the data back as a service. And a lot of that needs to be, updated in real time, and certainly high concurrency to support that sort of paradigm where you're giving that data product back to your customers. See it a lot in, these online companies, particularly like social media. In fact, Pachipino came out of LinkedIn. So a lot of when you're on LinkedIn and you're looking at who viewed my profile by country, by recruiter, by company, that's all in real time on multiple dimensions. It's all powered by Apache Pinot. We're seeing it in logistics. I mentioned DoorDash, Uber, because a lot of their data too is long lat, and we support the H3 index and a lot of geospatial efficiencies for crunching through those numbers.
Yeah.
See it in ad tech. Anywhere where there's big, fast-moving data, where making the right decision in a narrow, compressed time frame builds a lot of value.
That makes perfect sense. That and when you think about the Uber example, right? When I want to summon an Uber, I don't have time. And so being able to serve up that data super quickly, allow me to make a purchase decision, whatever, it makes perfect sense. I get, and the fintech ecosystem being, adopters of this makes perfect sense as well, right? You need to make those decisions quickly, and you need to have that data quickly.
The Uber ones, I think a lot of people can relate to that because they're Uber users.
Yeah.
But what's going on there? It's a two-sided marketplace, right? You have drivers, you have people that want rides. And pricing's dynamic. It's supply and demand. So when you log on and you put in your coordinates, you're right. You don't want to wait 2 minutes to get what the estimated fare is. That needs to happen.
Well, because that 2 minutes feels like 20.
For sure. 100%.
Because we're so patient, we consumers and users of technology.
Yeah.
So,
it changes the whole customer experience, right?
Absolutely.
A successful app and one that will flounder.
Absolutely. So with performance and scale being so crucial, we've just been talking about, what do you see as StarTree's key differentiator here?
Yeah, so StarTree, which is based on Apache Pinot, was really designed from the ground up to support two sides of the real-time equation. A lot of times when I'm talking with someone about real-time, they'll talk about, well, the queries are fast. Like we just said, it's like, I want the pricing for my Uber to be really fast.
Right.
Part of the equation. But the other part is the data has to be up to date. right?
Yeah.
Like I can't calculate the pricing if I only know who's available as a driver an hour ago or something. So this idea of data latency and query latency have to come together to really solve this problem.
Sure.
On the data latency side, one of the things that StarTree really helped pioneer is this idea of just streaming data from something like Kafka or other streaming tools directly into the database, no batching or even micro batching. And as it's coming into the database, all the reconciliations on upserts is happening in real time. It's being indexed in real time. So the data's made available for query like near instantaneously from the time the data is generated from the source. On the query side, just a load of different optimization techniques. Everything's designed to really scan less data and move less data. StarTree's, our company's name is named after one of such of those features, the StarTree index. And what that's doing is it's really getting ahead of what the most common query patterns are and pre-aggregating as soon as new data is coming in. So it essentially, again, dramatically reduces the amount of data needed to be scanned to ask very common questions.
Yeah. So constantly refreshing.
That's right.
Yeah.
And so you have companies, again, like an Uber, a Stripe, a DoorDash, where their data is no more than a couple seconds old, and their query times are measured in milliseconds, even when you've got like 20, 30,000 simultaneous users hitting the database.
Yeah. Very cool. Well, Chad, as we wrap this episode, what do you see as the biggest breakthroughs coming in real-time analytics? And yeah, that's my question right there. What do you see as the biggest breakthroughs ahead?
I mean, I see two big trends happening right now that'll just continue to grow the real-time analytics market. One is, we kind of touched on it, and that is AI. I think a lot of people are recognizing that, for their data platform to really support AI, the data has to be fresh because context is so important, right? As these agents are making decisions, and scale, right? And so the combination and intersection of what's going on in AI and real-time analytics, I think, is, again, a nice tailwind. The other thing that we're seeing, and our founder is actually going to be talking about this quite a bit at his keynote Wednesday at the Real-Time Analytics Summit, but we're seeing many companies now make this shift from real-time analytics as this one-off corner use case, like an exception to the norm, to now where you have companies that they'll say, oh yeah, I've got 80, 90, 100 different data products that absolutely have to be real time. And so they're starting to architect real time as part of, it's like a first-class citizen within their underlying data platform, versus, again, something that they had to get an exception to the norm because, this crazy group over here had some requirements that sort of bucked the normal trend. So I think both of those things are ultimately, in a very good way, like, really challenging us as a company to support those requirements.
Yeah, absolutely. All right, Chad. Well, that's a wrap for our K&Co Tech podcast today. Thank you so much for joining me and spending this time with me. I'm super excited to see what StarTree is doing on the next gen of enterprise intelligence and AI native real-time analytics, and the role that Bring Your Own Kubernetes is playing there. And I know that you have so many exciting things ahead. I'm going to include a link in the show notes to your event that you mentioned if people want to check that out. And I look forward to continuing to track your progress in the months ahead. You've got a lot of things to look forward to.
Well, appreciate it. Thanks, Shelley, for having us.
Absolutely. Absolutely. Well, to our viewers and listeners, thanks for hanging out with us today. To Chad Meley, SVP of Marketing and Developer Relations for StarTree, thank you for spending time with us, and we'll see you again next time.